Hi, I'm Anjana Vakil, independent software engineer and developer educator. I'm really excited to bring you this totally revamped version 2 of my course, Functional JavaScript First Steps, in which we take our first steps in hopefully a lifelong journey of learning this fascinating programming paradigm. In this course, we'll cover what a pure function is, and we'll work with recursive functions, immutable data, and all kinds of other tools that we will need in our functional programming toolkit. I hope this course helps you build confidence with functional programming and prepares you to dive deeper with the other functional programming courses on Frontend Masters.
Functional programming boils down to this one idea: pure functions. So when I say a pure function, what am I talking about? A pure function, one way to think about it, is something that, like all functions that we're used to writing, it takes inputs and it returns output. The difference between a regular function of the kind that we're used to working with every day in JavaScript and a pure function is that in a pure function, all that this function looks at in order to decide what its computation is going to be are the inputs that it receives. So it only takes its inputs in. It doesn't take in any other information about the state of the world, the weather today, the time it is, etc. Only its input arguments. And then all that it does is do whatever computation it needs to do and return its output. That is it. It doesn't do anything else, and we'll talk about what anything else might be in a moment. So a pure function is essentially a transformation from inputs to outputs, period. Done. So when we think about functions in JavaScript, we usually think about all kinds of other stuff that we can do, like talk to the browser, or make fetch requests, or write something to files, or what have you, and essentially talk to the rest of the world from within the function. In functional programming, that is not allowed. All the function looks at is its inputs, and all that it does is give it an output, and that's it. It doesn't look at any of the rest of the world, and it doesn't have any effect on the rest of the world. Its only effect is its return value. So, for example, we have a very simple function here called greet, where we just have one line and it's a console log. So, can anybody help me break down what is not pure about this greet function on the left side? Yeah.
Well, it's using name and it's not coming in as an argument. It's just using it from the higher scope.
Exactly. So one thing that it's doing is it's looking at data in the outside world, like in this case, the value of the variable name, that is not part of its inputs. So that's not allowed. Great. What about anything else? Yeah?
It's logging to the console, which is not a pure output.
Yes, exactly. Logging to the console is not the same as returning a value. What does this function return?
Void.
Yeah, undefined, right? Doesn't have a explicit return. And in JavaScript, that means it returns undefined. So if it's not returning its output value, and it's a pure, if it's not returning an output value, it definitely can't be a pure function because it's doing something else, right? And that means that if something changes, like for example, the value of that name, and I run the function again with the exact same inputs, in this case, no inputs, I might get a different value. It also means that, I don't know, the side effect of logging to the console, that might work differently in different situations, different environments, and so we might get a different side effect different times that I run this function. Now, a pure way of structuring this would be to make name an input to the function, so that way we're only looking at that data in order to make our computation, and then to return the output instead of logging it to the console. So this is a very, very simple, but I hope illustrative example of what we want to not do in our functional programs. In addition to functional purity, or sort of a consequence, again, of our wanting to do programming deterministically and with minimal cases where, like, the thing changed out from underneath me in a way I didn't expect, we want to avoid mutating data. So when I say mutating data, I don't just mean like getting it bitten by a radioactive spider and giving it superpowers. I mean like changing the data in place, we say, or sort of like the same entity, like an array, for example, now has different values inside of it. So that's what we call changing data in place and mutability. And in immutable land, we don't want to do that. We never want to, let's say we take in an array, we never want to mess with that original array that we took in. Instead of changing it in place, we want to replace it with an updated new version of the array without messing with the original version. So let's take a very simple array as an example. We've got a bunch of cities in an array that are cities in India that those names are super outdated and colonial and we don't like them anymore, some of them. So for example, Bombay, which is what the city, for example, my dad grew up in, which was called Bombay when I was a kid, is no longer called Bombay. It is called Mumbai. So we need to update this data, and in a mutating way, we could update it by assigning a new value, Mumbai, to the element at index 1 in the array, right? And we're used to doing this in our JavaScript code, hopefully reasonably often. And so now cities is different. Before, cities had Bombay in it. Now it does not. It has Mumbai instead. Cities itself, same array. As far as JavaScript is concerned, it's the same thing that it's pointing to in its memory. Okay, the problem with that is, okay, maybe we won't run into it in this particular case, but if an array or any kind of value changes out from under me, that means, again, we have state. We have a value that is changing over time. The single value, cities, is now talking about different data. So if I were to run a function that used cities at 2 different points, one before the update and one after, now I am having the pain of stateful headaches in my programming. So instead, what we want to do is not update the old data, the old object, in this case an array, but rather create a new one that has the correct data, or the updated data. So one way we could do that here is by using, in this case, we can use the built-in map. It's pretty pure. It returns a new array. It doesn't mutate the array, but we could also use our helper map function. We're going to take each thing in the array of the original old cities and then decide if we need to update it or not, essentially. And if we do, we will return the corresponding new value. So in this case, we're saying, okay, Delhi, yep, that's still Delhi, continue. Bombay, nope, new name, Mumbai. Bangalore, nope, new name, Bengaluru. So what we return then, and this is the inner function here, this transformer function that we pass in to our higher order map is then just going to take in the old data and return the new data. And map is going to take care of doing that for everything in the array and then returning a new array with that transformation. Crucially, old cities never changes. So if my coworker was like working with the old cities array and like their tests would fail if I swapped out all the values, they're still good. Old cities is still old cities. New cities is new data that I can work with that is based on that old city data. So let's just use array.map, which is, again, not mutating. And then what do we pass in?
I put in the item and then the index.
Okay, yeah, so if you're used to writing map functions that look like this, like item to item, which I think most of us are, don't forget, you also have the option in JavaScript map input functions, the transformer functions. If you add another variable here, that will be given the index of each element. So we can then use that to check if it's the correct index by checking the value of I. So if I is the index that we're interested in,
Then return the value, otherwise just the normal item.
oh no, sorry, value, you're right. Okay, so if we are at the stage in our mapping where we have reached the index that we are interested in, forget that original item and just return the value, and otherwise return the original item. Sounds good to me.